To another video. My name is Michael. I'm the founder of Buffalo Performance and Analysis, where we combine sports science, strength and conditioning, and sports performance to give coaches the tools necessary to build the next level of elite athletes. In this video, we're looking at the last step in our data analysis process, which is analyze. So we're going to be utilizing statistical analysis to analyze the data that we have. So I've already installed the Tidyverse and dplyr packages, and we are going to load and view a couple different data sets that we'll be using throughout this video. At a basic level, analyzing data just shows the statistical significance of different tests. Really important things that we need to use and look for are going to be mean and standard deviation, especially with the test that we're going to be utilizing today. So we're going to utilize the All Blacks data frame, and we're going to look for the mean standard deviation of both the result and the opposition rating. So when we run these two lines of code, it gives us the result, the mean, the standard deviation of the result, as well as the mean and standard deviation of the opposition rating. The reason that we're doing that is that we're going to utilize these data points to filter out data. So we're going to utilize 1.95 as our kind of range to filter out any outliers. The reason we use 1.96 rather, is because from negative 1.96 to positive 1.96 standard deviation, 95% of the values fall within that range, at least within a normal curve. So we're going to utilize 1.96 to get that 95% of values. So once we've calculated the negative 1.96 and positive 1.96 of both the result and the opposition rating, we're going to create a new data frame and call it AB_filter, and we're going to select only the result and the opposition rating, and we're going to filter where the values only fall within that 95% range. So we'll run this line of code right here, and then we'll view it, and we see that there are now only 191 entries, as opposed to the normal data frame there are 205. So the first statistical test that we're going to run is very simple. It's Pearson's R correlation coefficient. So we're going to use core, and then we're utilizing result and opposition rating. And essentially what we're trying to do is we're just determining what the relationship is between the result and the opposition rating. So when we run this line of code here, we see that there is a negative correlation of 0.6. And now the correlation of 0.6 is a moderate to high correlation. It kind of depends on which interpretation you're utilizing, but it's kind of a moderate to high correlation. So we see from the full data set with 205 entries that there's a moderate to high correlation, negative correlation, between the opposition rating and the result. However, when we utilize the filtered data frame, AB_filtered, we actually see that the correlation decreases, and now it's negative 0.4. So what that means is that some of the outliers that we eliminated in that filtered data frame actually caused the data frame caused the correlation coefficient to be skewed. By eliminating those outliers, we're able to get a better view of our data and the correlation between result and the opposition rating. And we can actually visualize this data as well. So using ggplot with geom_point and then geom_smooth with the method of a linear model, we can run it, and for the full data frame, we can see that there's kind of this sharp decline or the sharp negative slope, versus when we use the AB filter, when we run it, we can see that it's a more gradual slope. So another way is just by visualizing that data. So building off of Pearson's R, we can utilize a linear model to kind of learn a little bit more about the correlation between result and opposition rating. So we're going to create a model calling LM, and we're going to look at how the result compares to the opposition rating using the data frame of the All Blacks match data full. So when we run this line of code, then we have to call on the summary of that model, and that's going to give us a couple important numbers that we need to look at. So the first one that we're going to look at here is under estimate, and the opposition rating is that's going to be the slope of our line. So it's a negative 2.19 slope. And then the next one that we're going to look at is the p-value, a p-value of 2 to the negative 16th. So because it's such a small p-value, we're going to reject the null hypothesis. So we can assume that there is a significant or statistically significant correlation or relationship between result and opposition rating. Moving on from that, the next number that we're going to look at down here is going to be our r squared. We have an r squared of 0.3636, and that r squared just tells us how well the data fits the line, or the best fit line. So we ran it for the all blacks match data. Now we're going to go ahead and run it for the filter data frame. We're going to run the same lines, we're just calling it model 2. And we see that the slope now is a negative 1.36. So it's a little bit less steep of a slope. And we also see here, now the p-value is a little bit larger. So it's a little bit closer to 0. It's still extremely small. So again, we're going to reject the null hypothesis. There is a significant relationship between result and opposition rating. And then again, looking at our r squared, we see that it's much smaller. It's, instead of 0.36, it's 0.16. So the fit of the line is a little bit less than in our full data frame. Moving on, we can utilize a t-test to determine if there's a statistical difference in the means of two different groups. So what we're going to do for this data frame is we're going to create a new one, call it data frame 1, and all we're going to utilize is the opposition name and the result. And we're only going to utilize it where the opposition name is either Argentina or South Africa. I just picked these two teams at random, and it's going to make our analysis a little bit easier by creating a new data frame. So we're going to create the new data frame, we can view it, opposition name, result, South Africa and Argentina. Then we're going to utilize a t-test where the data, or the data frame that we're using, is df1, and again we're looking at the result on opposition name. So when we run that line of code here, we see that it actually gives us the answers that we need. So there's not as much interpretation that needs to be done. It gives us our p-value right here. Again, it's a very small p-value. It's below 0.05. And then it actually gives us that we should reject the null and accept the alternative hypothesis that there is a difference in the means. So running a t-test in R is a little bit better. It kind of gives you a little bit more information, and then it even shows you down at the bottom that the mean for the Argentinian matches is 21, while South Africa is 9 or 9.4. So a t-test is a great option. It gives you a little bit more information, and it's a little bit less of interpretation that you have to go through. The next statistical test that we're going to utilize is the ANOVA, or analysis of variance. ANOVA is very useful for determining whether or not different factors or different variables are related at all to each other, or if they're independent. So we're going to use ANOVA and using it as AOV, and we're calling on the All Blacks match data full. And in this instance, we're going to compare the opposition rating to the rating of the All Blacks. So we are expecting a high p-value because it wouldn't make sense for opposition rating and rating to be dependent on each other. So we assume that they're independent, which means that we're expecting a high p-value. So I've just ran those tests, and when I ran it, we see that we do have a large p-value. It's greater than 0.05. So we're going to go ahead and accept that null hypothesis, that there is no significant relationship or no significant difference between opposition rating and the rating of the All Blacks. The last test that we're going to look at today is the chi-squared test. The chi-squared test is great for analyzing categorical variables and showing if the distribution of those variables is statistically similar or different. So we're going to utilize a different data frame. We're going to utilize our injury record data frame, and we're going to be looking at the body part that was injured and the surface that it was injured on, so whether it was synthetic or natural grass. So when we run this one, we get a little warning message. I'm not too sure what that was about, but we see here that we have a p-value that is greater than 0.05. So we're going to accept the null hypothesis that there is no significant difference in the distribution of the different values. We're going to run it one more time. We're going to utilize another data frame. This time we're going to utilize playlist. We're going to look at the position of the player on the field type. So again, natural or synthetic for an injured athlete. So when we run this one, so we see that body part on surface, there's no significant differences in the body part that was injured. But when looking at the roster position on the field, we see that now we have this really, really tiny p-value of less than 2.2 to the negative 16. So we're actually going to reject the null hypothesis in this instance, and we're going to assume that there is a statistical difference in the roster position and the playing surface that the athlete was injured on. So it'd be really, really interesting to look into the roster positions, which positions were injured the most on what playing surface. So these are just some statistical tests that you can use in R, specifically when we're looking at sports data. If you enjoyed the video, please give it a thumbs up, comment, and thanks.